All right, good morning, everyone. This week is just going to be an introduction to the course itself, and we're going to get into a little bit about what Linux is. So as we talk about Linux, Linux is the kernel of the operating system, and the kernel and the suite of tools are packaged together in what's called a distribution. There's multiple different kinds of distributions of Linux. You primarily have the Debian kernel and distribution type. You also have a Red Hat distribution. Now there's flavors that come off of that. For example, Ubuntu is a Debian-based distro, and then CentOS is going to be a Red Hat-based distro. And there's many flavors of Linux out there today. So there's three main operating system components when it comes to a Linux system. You have the kernel, which is going to manage the operation of the computer. You have the shell, which provides an interaction between the user and the computer. And then you have the file system, which provides a way for you to organize and manage all the information on the computer's disks. The role of the kernel is the main program is loaded up at the startup, and that manages the operation of the computer. So it will manage devices, memory, processes, and it'll handle the switching of different applications, similar to like an air traffic controller at an airport. Applications themselves make requests to the kernel and receive resources such as memory, CPU, and disk in return. Applications will soon follow the kernel's application programming interface, or API. Historically, most software has been issued under a closed source license. That means that you have the right to use the executable program or machine code, but you cannot ever see the source code. With the development of Linux, it closely parallels the rise of open source software. So one tenet of the open source philosophy is that you have the right to access the source code and modify it as you wish. With Linux distributions, recall that a distribution will refer to a combination of the Linux kernel, tools, and the suite of applications that all come bundled together. There are distributions suited to every imaginable purpose. Those distributions will focus on either running as a server or a desktop, or even industry-specific tools like electronics design or statistical computing. In cyber security and forensics, data forensics, we also use a distribution like Kali Linux, which has a suite of applications designed to help a pen tester and allow them to access a network. Linux itself first ran on a computer similar to its inventors, a 386 with a specific hardware controller. The types of hardware grew from the humble Intel chip to eventually support even computers, supercomputers. Eventually, cellular phones and tablets adopted Linux as well. And aside from phones and tablets, Linux can be found in many consumer devices such as wireless routers. You can embed a lot of devices with Linux, and they usually base on a little Linux kernel. And they don't need much RAM and CPU to run for specific distros. The shell is a program that allows the user to type commands, options, and arguments. There's two types of interfaces. They're the graphical user interface, or otherwise known as the GUI, and you have the command line interface, or the CLI. Advantages to using the CLI include command repetition, command flexibility, resources, scripting, remote access, development, and much more. As you're working with this particular course, you'll be going through both the GUI in a little ways, but a lot of what you'll be doing is in the command line. As you want to know the heart of a Linux system, you have to do it through the command line. Most distributions will allow you to have some type of GUI so that you can have a desktop style environment. And then from there, you can launch the command line interface, generally referred to as the terminal. In a bash shell, many shell programs exist, and the most popular shell is bash, or born again shell. Users interact with a system by executing commands in which they're interpreted by the shell and transformed into actions by the kernel. So for example, here we are running the ls command, which is going to list all the different files and folders that are in that particular directory. You can see that you have a bunch of folders there, and I know they're folders by the blue color, and you guys will eventually learn that here as well. The bash shell itself has numerous built-in commands and features, including aliases, re-executing commands, wildcard matching, in and output redirection pipes, and background processing. So some features of the bash shell, again, it has built-in commands, binary commands stored in files. You can use aliases, which you guys will learn about. It's a way of shorthanding some long commands. You can write a real short command for that. And you can write some functions and also do straight scripting there as well. When you access this shell from a graphical user interface or a GUI, you're typically going to use the terminal program, as I mentioned before. You're also going to have the option of using the command line interface directly. A file system is going to be a hierarchy of directories and files with the root / directory at the top of the root directory tree. So you can notice this graphic down here at the bottom. You start at root or the slash, and then you work your way out. So you'll typically see an organization that looks something like this on a Linux system. Every distro has it slightly different, but the main concepts are there. You have a bin folder, a boot, dev, etc., home, lib, lib64, media, mount, opt, proc, root, sbin, serve, sys, temp, user, and var. Now, did I need to list all those out? I wanted you to understand that there's a wide breadth of main system files. If you're familiar or coming from a Windows operating system, you're probably used to the Windows folder and then a System32 folder, and maybe some of the other directories that are underneath of that. For example, your program files or program files x86 folder. Those have mappings and the equivalents of those within a Linux operating system. All right, that concludes this video, and we'll see you in the next chapter.